This is a video on consumer and producer surplus. If you're in my course, you can find the file attached in our section, so you might want to print that out to take notes along with me here. It says the consumer demand curve, P equals D of X, gives the price per unit that a customer is willing to pay for X units of a product. And we've talked about this earlier in the course, but just kind of a sketch of it here. Right, so if I had, this is x-axis, and remember, they told us what it is. X is the number of units. And, the y-axis here, really, we'll call it P, because it says P equals D of X, so we have P. And this, remember, is the price per unit. So this is the price per unit a customer is willing to pay, right? So the demand curve is about what the customer is willing to pay. And typically, you'll see these curves, decreasing. And this will be P equals D of X. And, the curve's decreasing because as there's more units, they want to pay a smaller price per unit. If there were less units, they would be willing to pay a higher price per unit. So, demand curve usually decreasing, not always. But that's the consumer demand curve, right? And we have consumer here. The producer supply curve, right, which, we're talking about here, P equals S of X, so it's for the producer, gives the price per unit that a seller is willing to accept for selling X units of a product. So, just a quick sketch of this as well. If you have X, again, X is in units, so it's the units of a product. P still is price per unit, right? So the axes are labeled the same because they're the same units. And then for the supply curve, usually these are increasing functions. So this is P equals S of X, which it shows here that typically, as they're selling more units, they will want to have a higher price per unit to make more money. If they're selling less units, the price will be less per unit. So let's talk about what we call the consumer and the producer surplus. So this definition here, it says suppose P is equal to D of X as demand function for a commodity. All right. The consumer surplus is defined for a point Q comma P as, so make sure you know when I say Q comma P here. All right, Q is the quantity, and then P would be the price per unit. It's kind of like our X and our P above, right? So the quantity and the price per unit. And when we talk about this, consumer surplus, maybe I'll kind of draw you a little sketch of it, because suppose that you had some sort of curve here. So X with the number of units, P as the price per unit, right? So this is X is number of units, P is the price per unit. And on this curve, it's some sort of function. I'll just draw it in here. And we'll call this P equals D of X, right? So that's what they're talking about. Right, this demand function is about the consumer, all right? And suppose that you were to go to some point Q comma P. So at some quantity, Q, all right? I'm going up here, the value for Y that goes along with it, following it this way, right from the point, would be some value capital P. So we got Q comma P. Well, remember, this is the number of units and this is the price per unit. So the amount of money that you're spending on what you're purchasing, right, the quantity times the price per unit, is actually given by this area here. So what I just drew in red gives you the area of, what this rectangle Q times P is, length times width, but it also is telling you, okay, when I purchase so many units of products times the price per unit, this will give me how much the total cost of it was, right? How much it cost the consumer. But according to the integral, right, if I was to look at the integral of this from 0 to q, right, the amount they should have paid is really what is the area under the curve. So you're actually got, it would be the whole area from the curve down up until q, because if you take the integral of this, which is in price per units, you would get the price, right, that they should have paid for q units. Well, this part up here, this little part I just drew in green, right, that's the difference between the area under the curve and the amount that you paid. In other words, this is the extra value you're getting for buying q units of the product at whatever price it is. So the consumer surplus is actually what I'm talking about right here. It's this area up here. And it's the extra value that you're getting for your purchase that you should have paid a higher amount. You should have paid the total area under the curve, but really you only had to pay what was within the rectangle for what you purchased. So the way we set up the formula for consumer surplus is that this is equal to the area under the curve, right, from 0 to q, minus the area of the rectangle of what you actually paid. That's the consumer surplus. So we have the integral from 0 to q of d of x dx, that's the area under the curve total, right, minus this rectangle, which is q times p. And this will give you whatever that green little space that I found up there was. That's going to be the consumer surplus, that extra value you get. So taking a look at this example below, it says find the consumer surplus for d of x equals x minus 8 squared when x equals 6. So first off, they're telling you what to use for your quantity, 6, right? And we want to find the corresponding p-value, in this case d of 6. So first we want to find d of 6. And d of 6 just means you're subbing 6 into here, right? So we had 6 minus 8 squared, that's negative 2 squared, which gives me 4. So we know d of 6 equals 4. So the point that I'm using, right, just to make sure we have it, the point would be 6 comma 4. We'll assume this is in the price is dollars per unit. So 4 is the dollars per unit, 6 is the quantity. Make sure you understand which part is which. So in other words, right, 6 is the quantity, and then 4 is the price per unit, so Q comma P. So they're asking us to find consumer surplus. Well, we're going to use our formula above, right? So consumer surplus, let's use CS for short there, is equal to, so the integral from 0 to Q. So remember, this should be, remember the integrals with respect to x, so this should be the x value here in case you're getting confused as to what it is, right? It's the integral from 0 to our x value, which is 6, because that's the quantity Q, of d of x. Well, what's d of x? d of x is x minus 8 quantity squared dx, and then minus, oh, what do we have? Q times p. Well, that's minus 6 times 4. Alright, so we're just substituting into our formula up here. Make sure you put that 0 to 6 because 6 is Q. Q times P here, 6 times 4. And now what we're going to do is we're going to simplify this. You know, to evaluate this integral, the first thing I'm going to do is expand this x minus 8 squared. So really this will be the integral from 0 to 6 of x minus 8 squared is going to give us x squared minus 16x plus 64 dx minus 6 times 4, which is 24. And then we'll evaluate this here. Maybe I'll bring it up here so I can work with it. It's equal to, let's integrate. So we have x to the third over 3 minus, this will be 16x squared over 2 plus 64x, taking the antiderivative there. We're going to evaluate this, remember, from 0 to 6, minus, we've got 24. Remember, that's on the outside of the integral. Evaluating this, we've got, substituting in 6, we'd have 6 to the third over 3 minus 16 over 2 will just cancel to an 8x squared, so minus 8 times 6 squared plus 64 times 6 minus, well, what happens when you substitute in 0 into here? Well, 0 times, this will be 0 cubed is 0, minus 0 squared is 0, plus 64 times 0 is 0. So this will all be 0. So I'm just going to put, minus 0 here, and then minus the 24. So this minus 0 is just me substituting the lower limit. Make sure you do check that to make sure it does come out to 0. Remember, if there's any exponentials in here, this doesn't all cancel out. In this case, it does. So simplifying here, I end up with 6 to the third over 3. If you want to take a look on our calculator, 6 to the third divided by 3, that's 72. So we've got 72 minus 8 times 6 squared. Well, 6 squared is 36. We're doing 8 times 36. This gives me 288 plus 64 times 6, which gives me 384. Minus 0 is just minus 0, minus 24. And then, really, we just add these up. So we got 72 minus 288 plus 384 minus 24, and adding those I get 144. Now remember what this is. I said, we're going to assume our price is in dollars per unit, right? That's what P was. So 144, we have dollars per unit. It's really the units of P times the units of Q. When you take the integral, right, it's units of your axes being multiplied together. Or you can think of it as like the area of whatever the 24 was, right, the Q times P. But that is 144. Well, price per unit times number of units is just the price, so it's $144. That's the extra value that you got by purchasing 6 units. So the consumer surplus is $144. Alright, we'll take a look at another example here. Next, let's take a look at the producer surplus. So it says here, suppose P equals S of X is supply function for a product. The producer surplus, right, is defined for a point Q comma P. Again, remember that's quantity and price per unit, and we'll have an equation here for it. Let me draw out the function again just to show what's happening. If we have X, remember, which is number of units, and we had P, which is our price per unit, then we had this function here which we'll call P equals S of X, right? That's a supply function they mentioned above. And what they're saying is there's some sort of quantity Q, right? It's an X value, number of units, and following this up to here, we have a price that would be associated with that, which we call capital P, price per unit. And so that's our point Q comma P there. Now let's talk about what this kind of represents. This is the producer supply curve, right? So it's the price they're willing to accept for selling a quantity Q units. But if you look at the area under the curve here, right, this would be the price that they should take in for selling a quantity Q, right? That would be the area under the curve here in green. So that would be how much they should take in. If you take the integral from 0 to Q, the area under the curve will tell you how much money they should be bringing in for selling that quantity. But what happens here is that when you charge a quantity Q at a price P per unit, you're actually making the area of the rectangle, right? Q times P will give you the price, right? The number of units times the price per unit, right? So number of units sold times the price per unit will give you this area up here. Well, this area up here, right, well, actually it'll give you the whole area, right? The area up here, though, taking this area of the rectangle minus this area under the curve, if you take the difference, this is actually extra money that they would be making for selling a quantity Q, because they should be making only the area under the curve. what they're bringing in is Q times P. So what's the difference between this rectangle, the full rectangle, minus this area here? Well, this is what we call the producer surplus. So setting up our formula, right, the area of the rectangle would be Q times P. That's how much money they're bringing in, right? So Q times P minus the area under the curve, which would be the integral from 0 to Q of this function s of x. Make sure you're using the correct function, right? It's supply function, and then dx. So this is a producer surplus. This is the amount of extra money that that the producer would get, right, for selling a quantity Q at a price P, price per unit. Let's take a look at this example here. So it says find the producer surplus for s of x equals x squared plus 2x plus 6. When x equals 3, so they're telling you what quantity, right? That's, you know, our value for Q. And the first thing you want to do is find s of 3. So s of 3 would be 3 squared plus 2 times 3 plus 6. 3 squared is 9, plus 2 times 3 is 6, so 9 plus 6 is 15, plus another 6, I get 21. So that means we know we have the point 3, 21. Remember that this is Q, this is P, so at a quantity of 3 units at $21 per unit. Going through this, now I'm ready to find the producer surplus. Producer surplus is always based off the supply curve, right? Consumer is based off the demand curve. So my producer surplus, I'll use PS for short here, is equal to Q times P, right? That's what it says up here. Q times P, the quantity times the price. So it'll be 3 times 21. It's the area of that rectangle minus the area under the curve. So minus the integral from 0 to, now remember, it's always from 0 to Q. It's an x value, so 0 to 3 of, here we have x squared plus 2x plus 6 dx. Right, and now we want to evaluate this. 3 times 21 gives me 63. Minus, we've got this integral we'll evaluate here. So we have minus, this will be x to the third over 3 plus 2x is 2x squared over 2 plus 6x. We're evaluating it from 0 to 3. Make sure you got that negative sign in the brackets after it. Simplifying here, I have 63 minus, these 2's will cancel inside of here. Substituting in, make sure this minus is getting substituted into everything that comes after this. So minus, we're subbing in 3, so we have 3 to the third over 3 plus 3 squared plus 6 times 3 minus substituting in 0. Well, substituting in 0 for all of these ends up being 0 to the third plus 0 squared plus 0. It's all going to be 0. But make sure you check that. Again, if there's exponentials, it won't always be 0. And then we'll simplify what we have. Well, what do we got here? We've got 63 minus 3 to the third over 3. That's going to be 27 over 3, so minus. This will be 9. Plus 3 squared is 9, plus 6 times 3 is 18. And this is equal to distributing. Well, actually, I don't distribute. I'll just combine those, and then I'll just subtract. So 63 minus 9 plus 9 is 18, plus 18 gives me 36. 63 minus 36, that equals 27, and that's 27. What are the units on this? Well, it's the units of, you know, Q times P. It's the area under the curve, right? So it's the area of the rectangle. The difference between the area of the rectangle and the area under the curve, but they're in the same units, which is $27. So the producer surplus when 3 units are sold is $27. Right, we'll just look at one more example here. If I said this one here, It says given d of x equals x squared minus 16x plus 64, and s of x equals x squared, the first thing it says to do is determine the equilibrium point. So when I say determine the equilibrium point, this is drawing on something we've talked about earlier in the course. The equilibrium point would be where the demand and supply curves intersect, right? It's really the point where deals typically get done. So if I'm looking at this point for the equilibrium point, what I'm really going to do is I want to set the two functions equal to each other, because this will be where the two curves intersect. So what I really want to do is I want to take d of x and set it equal to s of x, and then solve. Well, d of x, we have is x squared minus 16x plus 64 is equal to s of x, which equals x squared. And then we'll, solve this. I'll subtract x squared from each side. Usually you want to get, the terms all on one side when you're solving a quadratic and 0 on the other. In this case, the x squareds cancel. They also cancel here. We have minus 16x plus 64 equals 0. To solve this, I'll subtract 64 from each side. We have negative 16x equals negative 64, and then we'll divide by negative 16 and divide by negative 16. So I get x equals 4. Now remember, that's the x value of the point where these two curves intersect, which is good. You found x equals 4. 4 is the quantity, in other words, because these are demand and supply curves. So 4 is the quantity at which they intersect. Well, what's the price? Alright, so now we got to sub in. Alright, so now we'll sub in, doesn't matter to which one, right, into either original to find the y value. In this case, the y value, remember, is the price per unit. So I'll just use the supply curves, easier to work with, right? Just one substitution. So I'll take s of 4, which equals 4 squared, which equals 16. So the equilibrium point the equilibrium point x comma y is 4 comma 16. And in our case, what we've been talking about, right, this would be our quantity Q at the price per unit P. So it would be 4 units at $16 per unit. And that would be us finding the equilibrium point. Right. If you had subbed 4 into the d of x function, taking d of 4, you still would have gotten the same answer. It's just a matter of, this was quicker to get the y value that way. So we found the equilibrium point, and that was part A. The next part of this is just going to ask you to find the consumer and producer surplus. So the consumer surplus at the equilibrium point. All right, consumer surplus, when you see this, you should think of, okay, I'm using the demand curve, right? So for consumer surplus, use the demand curve always. And remember, we talked about the formula for it, so we'll write it out here just so you have it again. All right, so the formula for the consumer surplus, remember, was equal to, it was the integral from 0 to q, right, of d of x dx minus q times p. And what's q and what's p? Well, at the equilibrium point, remember we just found the equilibrium point, that was the point that we just talked about, the 416. So remember, q is always the quantity, p is the price. So we're going to substitute into this. This will be the integral from 0 to q. What's q? Well, q is the quantity, it's 4. It's always the x value when you're integrating with respect to x. And then dx, that's a demand curve. Just going back to the previous page, demand curve was x squared minus 16x plus 64. So we're taking the integral of that. So x squared minus 16x plus 64 dx minus q times p. Remember, it's the actual 4 times 16. You're multiplying those together. Right? If you want, you can put parentheses to show the multiplication. What you do need to know is that it's not part of the integral. Right? After the dx, this is all a separate term. Alright, so we're ready to integrate this now. I've got x to the third over 3 minus 16x will be minus 16x squared divided by 2 plus the antiderivative of 64 is 64x. This is getting evaluated from 0 to 4. Minus 4 times 16, so minus 64. And then from this point we're going to evaluate. The 16 and 2 will cancel to an 8x squared here. Substituting in 4, the upper limit of integration, we would have 4 to the third over 3 minus, this is 8 times x squared now, so minus 8 times 4 squared plus 64 times 4 minus substituting in 0. Substituting in 0 into this, you get 0 to the third minus 0 squared plus 0 is all going to be 0. So minus 0. Make sure you check that though. And then minus 64. And now we're going to simplify this. I end up with 4 to the third is 64 over 3 minus 8 times 4 squared. That's 8 times 16, which gives us 128. So minus 128 plus 64 times 4, which is 256, minus 64 here. And combining these, 64 over 3, I'll handle that in a minute. Negative 128 plus 256, that would be 128. 128 minus 64 will be plus 64. And, you know, if you're leaving this as fractions, you could, you know, rewrite these using a common denominator, 64 over 3 plus, how do I write 64 as something over 3? Well, this is 64 over 1, so 1 times 3 got me 3. 64 times 3 gives me 192. 64 plus 192 comes out to 256 over 3. And since we're talking about what? We're talking about money, right? This is going to be the consumer surplus. Well, you know, around this 256 divided by 3 comes out to 85.333. Repeating, we're going to do this as 85, right, 0.33. Remember, money, 2 decimal places for the change, so $85.33 will be our consumer surplus. Alright, lastly, we're going to talk about the producer surplus. This producer surplus, alright, when you see producer surplus here, that's telling you to use the supply function. So supply functions for the producer, it's the number of items they're going to produce at that price per unit. So we're using S of X here. Right, at the equilibrium point, again, we know the equilibrium point, we found it in part A, is 416. And just to make sure we remember it, I'll rewrite the formula for the producer surplus. Remember, for the producer surplus, this is Q, this is P. It was Q times P, right, the quantity times the price per unit, minus the integral from 0 to Q, right, because that's the x value, 0 to Q, of the function S of X, right, for producer using S of X, dx. And then we will substitute in and evaluate. So this is equal to Q times P, well, it's the 4 times 16, it's the area of that rectangle, minus the area under the curve, so minus the integral from 0 to Q, which is 4, of S of X, just going back a page, remembering it, S of X was equal to the X squared. Make sure you're using the correct function here. If you're not, you won't get the same answer. So X squared dx. And now we're ready to evaluate 4 times 16 gives me 64, minus taking the integral here, x squared would be x to the third over 3. We're evaluating that from 0 to 4. And then we're going to simplify. Simplifying this gives me 64 minus x to the third would be 4 to the third over 3. Make sure this minus belongs to everything after this. I'm going to put minus 0 to the third over 3 here, just to make sure you understand I'm substituting in 0 as well. The 0 to the third over 3, that part's just going to be 0. So I end up with 64 minus 4 to the third would be 64 over 3. Simplifying here, this is equal to, if I wanted to write these both with a common denominator 3, 64 over 1 is equal to what over 3? We kind of talked about this a minute ago. 1 times 3 gives you 3. 64 times 3 gives you 192 minus 64 over 3. 192 minus 64, I get 128 over 3. And then, remember, we want this to be money. We're talking about the price, right? So 128 divided by the 3 is 42.6. If you look on here, 42.6 repeating. We're going to round to 2 decimal places, so since that's a 6 after it, we round up. So this would be $42.67. That would be the producer surplus. Alright, so we found consumer surplus, we found producer surplus. It's important to understand how to find each of them. Typically, you'll see an example like the one we just did, where we'll ask you to find the equilibrium point first, and then find the consumer surplus and the producer surplus. But you could be asked about them individually. Make sure you know the difference between the two formulas, and make sure that you know which curve you're using with which formula. For the consumer surplus, using the demand curve. For the producer surplus, use supply curve.